Hi dear friends, myself Irshad, faculty of KNA. So welcome all to KNA and Neet Mission 15 days. So today we'll be discussing few questions from the chapter solid state solutions and also from chemical kinetics. So as you know, the Neet exam is far approaching and we should be get prepared. So we'll be doing some numericals based on some of the important numericals based from these particular chapters, right? So we'll move on to the chapter and we'll go to the first question. See, which of the following defect decreases the density? And you know, it's a question from solid state, and the different types of defects are provided, like the interstitial defect, vacancy defect, Frenkel and Schottky defect. So we should consider, we'll see each defect one by one. As you know, in case of interstitial defect, some of the particles will be present in the interstitial site. So if these are the particles, and you know about the voids present in these particles. Now here, some in case of interstitial defect, some external particles will be present, or the particle which is already present, in a particular position will be moving to the interstitial site, so that it does not decreases the density. Now if you take the case of vacancy defect, in the second type, in vacancy defect, some of the particles will be missing from the normal lattice site. So for example, if you take the case of, if you are having like particles A present in all the site, some of the particle will be missing. So there will be a decrease in the mass. When the mass decreases and the volume remains the same, there will be a decrease in the density. So here the vacancy defect decreases the density of the substance. Now in case of Frenkel defect, you know, the particles will be present, already will be present in the site, especially a cation will be moving to the interstitial site. So there is no difference in the mass. And also in the case of Schottky defect, both the anions and cations, okay, positively and negatively charged particle, equal number of anions and cations will be missing from the normal lattice point. So here Schottky defect will also lower the density. So out of this one, 2 and 4 will be lowering the density. So the option will be B. Okay. Hope it is clear. Now we'll move on to the next one. In FCC arrangement of atoms A and B, where atoms A are at the corners of the unit cell and B atoms are present at the face centers, 2 atoms are missing from the 2 corners in each unit cell, then the simplest formula of the compound. So it's mentioned that the particle is having an FCC type of arrangement. When particle is having an FCC pattern of arrangement, as you know, the particle will be present in the corners as well as at the face centers of the unit cell. And we should know like the contribution. When an atom is present at the corner, so apart from the question, we'll have a basic idea. Now, when the particle, when they are present at the corner of the unit cell, okay, when they are present at the corner of the unit cell, 1/8 will be the contribution. When it is present at the face center, when a particle is present at the face center, the contribution by that particle to that particular unit cell, as you all know, it will be 1/2. Now, when it is present at the center or the body center, that means that particle completely belongs to that particular unit cell. And now, when it is present at the edge center, when a particle is present at the edge center of a unit cell, its contribution will be 1/4. And you know, if you take the total number of corners, that will be, you'll be having a total of 8 corners, isn't it? Then face centers will be having 6 face center, 1 body center, and 12 edge center for a particular unit cell. Now here, the particle is having an FCC arrangement where A atoms are located at the corners of the unit cell. But it is mentioned that 2 atoms are missing from the 2 corners. So we'll calculate the number of A atoms, okay, number of A atoms will be, now you'll be having a total of 8 corners, but out of that 8 corners, 2 of the atoms from the corners are missing, means there are only 6 atoms will be present. That means 6 atoms are occupying the corners. So the total volume occupied, or the total number of atoms of A will be 6 into 1/8, okay, 6 into 1/8, or we'll write it as 6/8, or that's equal to 3/4. Now atoms of B are located at the face centers. Okay, so number of B atoms B atoms will be, so you'll be having a total of 6 phases, and 1 by 2 will be the contribution. So that's equal to 3. So you are having, like, now we got, now number of A atoms is equal to 3 by 4 and number of B atoms is equal to 3. Now we need to calculate the formula. Now the formula, all the answers are given like A and B. So we'll calculate A is to B. So A is to B will be like 3 by 4 is to 3. Now 3 by 4 is to 3 means now we need to go for a simplest formula. So 3 by 4 is to 3. So we'll go for the simplest formula by multiplying by 4. So we'll get 3 is to 12. 3 is to 12 or 1 is to 4. So A is to B, the ratio of A is to B is 1 is to 4. So the formula will be A, B, 4 or 1 is to 4 means A1, B4. So we can take option D as the answer for this question. So the only thing that you have to consider is that the particle, the contribution from the corner will be 1 by 8. Then face center, as I told, 1 by 2, body center 1, and from edge center it will be 1 by 4. And also here the question may be like different types of question they may ask, like the particle, like four of the corners are occupied, or 2 atoms are missing from the face center, like any question you'll be getting. So depending upon the question, you calculate the number of atoms present in the unit cell. So here this will be the answer, so AB4. So now we'll move on to the next question. The edge length of a face-centered cubic unit cell is 508 picometer. If radius of cation is 110 picometer, then what is the radius of anion? So here it's mentioned that it's an FCC type of crystal. So in case of FCC, we know that radius of cation plus radius of anion, that's equal to edge length divided by 2. So this is the formula that we are going to apply in this question. So the edge length of face-centered unit cell is 508. That means A is mentioned. A is equal to 508 picometer. And also listen, all the answers are also given in picometer. So no need to change the unit. That also you have to take care. Like sometimes the edge length will be given in picometer and the answers may be nanometer or in angstrom unit. Then you have to do the conversions accordingly. Now, the radius of cation is given, that means R plus, or radius of cation is given as 110 picometer. So it's a direct application, so we'll calculate. So only thing is that you should know this formula, radius of cation plus radius of anion is equal to A by 2. So radius of cation is equal to 110 plus radius of anion is equal to 508 by 2, so that is equal to 254. So radius of anion will be 254, so minus 110, so that's equal to 144 picometer will be the answer. Okay, option B will be the right answer. It's a direct question, only thing is that we should know the formula, radius of anion plus radius of cation, that's equal to A by 2. Okay, then next one. Now it's a question based on the octahedral and the tetrahedral voids, which is like more important. Now a compound is formed by 2 elements X and Y. Atoms of element Y make CCP and those of element X occupy all the octahedral voids. So what is the formula of the compound? Now listen, when we are getting such a question, we should know like which is the atom which makes the unit cell, because there should be an atom that makes the unit cell, and after that these atoms will be making these voids, isn't it? We have a formula like if n is the total number of atoms present in the unit cell, then the number of octahedral voids will be similar to the number of atoms. Means if it is X, then you will be having X number of octahedral voids. And tetrahedral voids will be double in number. Like we'll be having 2n numbers of tetrahedral void, or 2x numbers of tetrahedral void will be present. So in this question, the compound is made, the atoms of element Y make CCP pattern. Okay. So the main element, so that the unit cell is made by the atoms of Y. So whatever be the pattern of arrangement, anyhow, we have atoms of Y which is responsible for to make that particular unit cell. And as a result of this arrangement of atoms of X, they'll be making that both octahedral and tetrahedral void. Now, to those octahedral voids which are created by the atoms of X, the Y atoms or X atoms are, that means the voids are created by Y. So these voids are occupied by X atoms. Okay. So we'll take like the main atom which is making the unit cell, that is like Y, and let the number of Y atoms, let it be equal to n. Okay. So let So let number of y atoms, okay, y atoms that's equal to, we'll take it as n. And we know that the number of, because here we are concerned about the octahedral void, because the x atoms will occupy all the octahedral voids. So we'll be having, so number of octahedral voids that's equal to n itself, because if n is the number of atom, then we'll be having n number of octahedral and 2n number of tetrahedral void. And here, since x occupy all the octahedral voids, means the number of x will be equal to the number of octahedral void. So here number of x that's also equal to n. So you have n number of y and n number of x, and here the answers are given as x and y. First it mentioned x and the second one it is y. So we'll take the ratio of x and y. So x is to y, so that's equal to n is to n. So which is equal to 1 is to 1. So the formula will be x1, y1, or the formula will be xy. Okay. So if the same question is like y atoms occupy all the tetrahedral voids, if that means if x atoms occupy all the tetrahedral voids, means then number of x atoms will be 2n. That means you will be having 2n number of tetrahedral voids, and the formula of the compound will become xy2 if the case is for tetrahedral voids. But for this particular question, they are asking only about the case of octahedral voids. Hope it is clear. So we will move on to the next one. The correct order of packing efficiency in different types of unit cells. So packing efficiency, as you know, it is the percentage of the volume occupied by the atoms in a particular unit cell. So we have an equation to calculate the packing efficiency. So packing efficiency will be equal to, packing efficiency is equal to, now Z into 4 by 3 pi r cube. So Z represents the total number of atoms present in a unit cell, and into 4 by 3 pi r cube means that is the volume occupied by one atom divided by volume of the unit cell. Volume of the unit cell is a cube, if a is the edge length, into 100 will give you the packing efficiency. And if the question is for packing fraction, we don't want to multiply by that 100. That means Z into 4 by 3 pi r cube divided by a cube is enough. So that will give you the packing efficiency, and we are not calculating the value, so you have to, it's better to by heart. I hope you all know the packing efficiency values. Now if you take the case of FCC pattern, in case of FCC pattern, the packing efficiency will be 74%. Okay, the packing efficiency will be 74%. In case of BCC, if it is body centered cubic, 68%. 68% of the volume will be occupied by atom. The remaining will be the empty space, which we call it as voids. Then in case of simple cubic, the percentage will be like 52.36. So these are the packing efficiency value. So the maximum packing efficiency is for FCC, then BCC, and the least for simple cubic. So here we can say that FCC greater than BCC and BCC will be greater than simple cubic. Okay. And also, like sometime the question will be like, what is the packing fraction? Instead of the value, you will be giving like pi by 6, etc. must be applied. For that one, we should know all these values. Now listen. So we are mainly dealing with FCC, BCC and simple cubic. So the pattern, the type of particle, okay, the type of particle, if it can be simple cubic, then it can be FCC and BCC. Now the number of particles Z in each type of unit cell. The number of particles in each type of unit cell in simple cubic, the number of particles will be equal to 1. So Z is equal to 1. In case of FCC, Z value will be 4, and in BCC, Z is equal to 2. And we should know the relation between edge length and radius. Now the relation between edge length and radius, okay, the relation between edge length and radius. In case of simple cubic, edge length A is equal to 2r. In case of simple cubic, A is equal to 2r. In FCC, that will be A is equal to 2 root 2r. And in BCC, A is equal to 4r by root 3. So you know the value of A and you know the value of Z. And we have the equation for packing efficiency. So the equation for packing efficiency will be like Z into 4 by 3 pi r cube divided by A cube into 100. Okay. So you know the value of A. So you can substitute A cube accordingly. If it is simple cubic, instead of A, you give it as 2R. Okay. So it will become 2R whole cube. So you'll get the result accordingly. Okay. So if you cannot remember, so you can use this formula also. Z into 4 by 3 pi r cube divided by A cube into 100. Okay. Now the answer for this one is FCC greater than, BCC greater than simple cubic. Option B will be the answer for this one. Then next one. For orthorhombic system, axial ratios are given like A not equal to, B not equal to C, and axial angles. So what should be the axial angle for the orthorhombic system? So it's a very direct question, and we should know all these values. Only that is the concern in this question. So you know about the types of crystal system. See, there are around 7 types of crystal system, which are cubic, then tetragonal, orthorhombic, then hexagonal, rhombohedral, monoclinic, and triclinic. So these are the different crystal systems. So we call it as the 7 crystal system. And in these 7 crystal systems, you know about the Bravais lattices. The total number of Bravais, so sometimes the question can also be like that, the total number of Bravais lattices. So the total number of Bravais lattices will be 14 in numbers. We'll be having a total of 14 Bravais lattices, and the number of crystal system is equal to 7. And now here, for orthorhombic system, so orthorhombic system means here, this is one. So here it will be like they are provided A not equal to, A not equal to, B not equal to C, and alpha equal to beta equal to gamma equal to 90 degree. So that is the value for orthorhombic. And in case of cubic, you know about A equal to B equal to C, and alpha equal to beta equal to gamma equal to 90 degree. And now here you should know that the most symmetric one, the most symmetric system, okay, the most symmetric one will be the cubic system, okay. Now you may get a question like which among the following is most symmetric. So the most symmetric cubic system or the most symmetric system will be the cubic, and the most unsymmetric will be triclinic, because in triclinic you are having A not equal to, B not equal to C. That means the edge length are called A, B and C, and the axial angle alpha, beta and gamma. So the alpha not equal to, beta not equal to, gamma not equal to 90 degree. So the most symmetric system is cubic, and the most unsymmetric system is triclinic. Okay, for this one, so our answer will be option B itself. So A equal to, B equal to C, and alpha, no, that means if A not equal to, B not equal to C, and for orthorhombic system, alpha equal to, beta equal to, gamma equal to 90 degree. And also should remember about 14 crystal system. And now in this question, like they'll be asking about the different types of particle which is observed in this type of crystal systems. Okay. Now listen. Okay. Now in case of cubic, tetragonal, orthorhombic, hexagonal, rhombohedral, monoclinic and triclinic. Now first of all we'll see the case of primitive. Now all these systems can have a primitive pattern of arrangement. That means in cubic, tetragonal, orthorhombic, in all these systems you are having the primitive pattern of arrangement is possible. Okay, primitive will be possible. Now if you take the case of BCC pattern, in this case like BCC will be available in the first 3. Then FCC will be available in 1 and 4, that means in cubic and orthorhombic, and in end-centered will be possible in orthorhombic and monoclinic. So here see, orthorhombic system will have the maximum number, of patterns of arrangement. Okay, orthorhombic system will have the maximum pattern of arrangement, that means primitive, BCC, FCC and end-center. So the question can also be which is the system that is having maximum number of arrangement. So the system that is having maximum number of arrangement will be the orthorhombic system. Okay. Now anyhow, for this question it is alpha equal to beta equal to gamma equal to 90 degree. Then next one, in a cubic packed structure of mixed oxide, the lattice is made up of oxide ions and 1/5 of the tetrahedral voids are occupied by divalent ions, while 1/2 of the octahedral voids are occupied by trivalent ions. Then the formula of the oxide. So it's the same question that we have done in the previous section, like the case of octahedral and tetrahedral voids. Now in a cubic packed structure of mixed oxide, the lattice is made up of oxide ions. That means the entire crystal lattice is made up of oxide ion. So we have to consider oxide ions. Okay, so the unit cell is made up of oxide ion, and these oxide ions are making some types of voids. So it can be like tetrahedral void and octahedral void. So we'll take it as the number. So we need to take the main atom. So let the number of oxide ions. Okay, let the number of oxide ions. Let number of oxide ions. Okay, that is equal to n. We'll take it as n. Then the number of tetrahedral voids will be 2n in number. So 1/5 of the tetrahedral voids are occupied by divalent ions. So number of divalent ions x. So 1/5 of the tetrahedral voids are. So the total number of tetrahedral void will be 2n, and 1/5 means into 1 by 5. So that will be equal to 2n by 5. 2n by 5 numbers of x atoms or x ions will be present, and 1/2 of the octahedral voids are occupied. Okay, 1/2 of the octahedral voids are occupied by y atoms. Okay, y ions. So number of y ions. So you know that octahedral void will be n in number, and 1/2 of the it is occupied means that will be n by 2. N by 2 will be the number. So you have n numbers of oxide, then 2n by 5 numbers of x, and n by 2 numbers of y. So we'll see the formula is given in the ratio x is to y is to o. So in the answer it is given in that ratio. So we have to find what is the ratio for x, y and o. So we'll calculate it as x is to y is to o. So x will be like 2n by 5. Okay, so 2n by 5 is to y, n by 2, and oxide is given. We took it as n. So all the n will be cancelled. Okay, so we'll get 2 by 5 is to 2 is to 1. Sorry, 1 by 2 is to 1. Okay, 2 by 5. So through will multiply by 10. So we'll get 10 into 2, 20 by 5. So that's equal to 4. So 4 is 2. Then 10 by 2, 5. And 1 into 10, that will be 10. So the ratio must be in the like 4 is to 5 is to 10. So 4 is to 5 is to 10 means x4, y5, O10. x4, y5, O10 will be the formula of the compound. Okay. Now we'll move on to the next one. Now AB crystallizes in a body-centered cubic lattice with an edge length of 387 picometer. The distance between two oppositely charged ions in the lattice is. Now here it's a question based on body-centered cubic, BCC. So we know that in BCC A is equal to, or we'll take the case of radius of anion, radius of cation plus radius of anion, that's equal to A root 3 by 2. So they are asking the distance between two oppositely charged ions. So that means you should know the radius of anion plus radius of, that means you have anion and cation, and the distance between the radius of anion and cation will calculate radius of cation plus radius of anion. So the answer will be A root 3 by 2. So A root 3 by 2 means edge length is given as 387 picometer, and all the answers are also given in picometer itself. So that will be 387 into root 3, 1.73 divided by 2. So 387 into 1.73 by 2. So here 1.73 by 2 will be a fraction, isn't it? So here on solving, you'll be getting the answer as 335 picometer. Okay. So definitely the answer will be less than 3, because all the answers given it is less than 385 itself. Okay. So anyhow, if you're on solving, you'll be getting the answer as 335. So here the answer is 335 picometer. So remember, in case of BCC crystal, in case of BCC crystal, radius of cation plus radius of anion, that will be equal to A root 3 by 2 will be the answer. Then next one, the total volume of atoms present in a BCC type of unit cell. It's a very easy question. So the volume occupied by one atom will be 4 by 3 pi r cube, and in BCC you are having two atoms. Okay, so the answer will be 2 into 4 by 3 pi r cube. 2 into 4 by 3 pi r cube will be the total volume occupied. So 8 by 3 pi r cube will be the answer. Now which defect is shown in the given figure? So you are having Na plus and Cl minus in alternate locations, and you can see that SR2 plus is occupying the one of the position of that Na plus is occupied by SR2 plus, and also at one site for Na plus is missing. So it refers to the impurity defect. That means molten sodium chloride is crystallized with the strontium chloride. So when one SR2 plus when it enters to the crystal lattice, two numbers of Na plus will be missing, and it creates two cationic site, and one of the cationic site will be occupied by Sr2 plus, and the second will be remaining as a vacant site. So it refers to the impurity defect. Then the number of atoms in 100 gram of an FCC crystal with density 10 gram per centimeter cube and an edge length of 100 picometer. Listen, you are asked to calculate the total number of atoms. Okay, so we know that the number of atoms can be calculated. Number of atoms is equal to N into Na. Number of moles into Avogadro number, or that's equal to given mass by molar mass into Avogadro number. And then the density is given, but we have here the M is given as 100 gram, and Na value also we know that 6 into 10 raised to 23. Then the case is that capital M is not provided, but instead they have given the density of the substance is provided. So we know that density is equal to Zm by A cube Na. Density equal to Zm by A cube into Na. So density is equal to Zm by A cube into Na, where capital M is equal to dA cube Na divided by Z. Capital M is equal to d A cube Na divided by Z. So we'll substitute the value of capital M here. So number of atoms N is equal to small m into Na divided by d A cube Na divided by Z means into Z. So we'll cancel out the Na and Na. So number of atoms. So finally the number of atoms N is equal to m into Z divided by d A cube will be the answer. So mass is given as 100 gram. So 100 into FCC pattern it is mentioned. FCC pattern means Z is equal to 4 in FCC. Density is given as 10 gram per centimeter cube, and A cube edge length is given as 100 picometer. 100 picometer and density is given in centimeter. So we know that 1 picometer will be equal to 10 raised to minus 10 centimeter. So 100 picometer will be 10 raised to minus 8. Okay, so 10 raised to minus 8 whole cube. So here this will be equal to 100 into 4 by 10. Now 10 raised to minus 8 cube is 10 raised to minus 24, and it will become 10 raised to 24. So here 10 and 10 cancel. So 4 into 10 power 25 will be the answer. Okay, 4 into 10, that means 10 into 4 into 10 raised to 24. So you can get 4 into 10 raised to 4 into 10 raised to 25 will be the answer. So you can apply the formula. Number of atoms is equal to m into Z divided by density into A cube. Okay, next one. Now these are the questions from the chapter solutions. Okay, now an X molar solution of compound in benzene has a mole fraction of solute to 0.2. So what is the value of X? So here we need to have a relation between the molality and the mole fraction. Okay, so the relation is that molality M is equal to M is equal to mole fraction of solute into 1000 divided by 1 minus mole fraction of solute into molecular mass of solvent into Ma. So you can apply this formula. So here the x molal solution. So we need to find what is, so let it be x. Okay, molality is given as x and mole fraction of solute is 0.2. So 0.2 into 1000 divided by 1 minus psi b, that's equal to 0.8 into, now the solvent is benzene. Okay, so the molecular mass of benzene is 78. So on solving this one, you will be getting like 200 divided by 0.8 into 78, and the answer will be around 3.2 will be the answer. Okay, on solving this one, you will get the answer around 3.2. Now next one. So remember the formula. Okay, that means molality. Molality is equal to mole fraction of solute into 1000 divided by 1 minus mole fraction of solute into molecular mass of the solvent. Then 1 molar 2.5 liter sodium hydroxide solution is mixed with another 0.5 molar 3 liter sodium hydroxide solution. So what is the molarity of the resultant solution? It's a very direct equation. So we know that resultant molarity is equal to m1 v1 plus m2 v2 divided by v1 plus v2. So this is the equation that we'll be using to calculate the resultant molarity. And here, see, the molarity values are given as 1 molar. Okay, so the first solution is having a molarity of 1 molar and second solution is having a molarity of 3 molar. So definitely the answer will be between 1 and 3. That means the molarity will not go less than 1 and it will not go above 3. So we'll apply the formula. M1 V1 means now 1 into, so molecularity M1 is 1 molar, 1 into 2.5 plus M2, 0.5 into 3 divided by 2.5 plus 3 will be the answer. So 2.5 plus 0.5, 0.5 into 3 will be 1.5. So 4 divided by 5.5. Okay, 4 divided by 5.5. So the answer will be around, it will not be 1. So it will not be 0.5. So the answer will be around 0.73. Okay, the answer should be like solving this one. You'll be getting an answer around 0.73. Then the mole fraction of solute in 1 molar aqueous solution is, okay, the mole fraction of solute in a 1 molar aqueous solution is. Now they are given as the values are given. So we know that the mole fraction of solute chi b, that's equal to number of moles of solute divided by Nb plus Na, total number of moles. So here it is mentioned as a 1 molar aqueous solution. 1 molar aqueous solution means, because we know that molality is the number of moles of solute dissolved per liter of the, or per kilogram of the solvent, because molality is the number of moles of solute Nb dissolved per kilogram of the solvent. And now 1 molar means it will be like 1 mole of solute dissolved in 1 kilogram of solvent. So Nb value that will be equal to 1. And then number of moles of solvent Na. So it is mentioned as aqueous. Aqueous means the solvent will be water. And also we know the weight, that means in 1 kilogram of solvent, 1 kilogram means 1000 grams. So Na is equal to given mass divided by molar mass, given mass by molar mass, that's equal to 1000 divided by 18. And remember, or try to by heart the value, that's equal to 55.55, because this 1000 by 18 always comes in a calculation, okay, in chemistry. Now we'll apply the values. So on applying the values, you'll be getting Nb, that's equal to 1 divided by 1 plus 55.55. So the answer is around 0.0177. So we'll get the answer as 0.018. Okay. And if it is 2 molar aqueous solution, then the answer will be 2 divided by 2 plus 55.55. Or if it is 10 molar, it will be 10 divided by 10 plus 55.55. Okay. Then on adding a solute to a solvent having vapor pressure of 0.8 atm, vapor pressure reduces to 0.6, then what is the mole fraction of the solute? So it's a question related to relative lowering of vapor pressure. So according to the equation, we have a P0A minus PA divided by P0A is equal to mole fraction of solute. P0A minus PA divided by P0A, that's equal to mole fraction of solute. And on adding a solute to a solvent having a vapor pressure, so the solvent is having a vapor pressure of 0.8 atm. That means the pure solvent P0A is given as 0.8. So you have a pure solvent like here. So its vapor pressure is 0.8. And on adding a solute, when a solute is added, so when a non-volatile solute is added to it, its vapor pressure is reduced from 0.8 to 0.6. That means PA value is equal to 0.6. Okay, you are getting the PA value as 0.6. And now we'll apply the, because we know that P0A minus PA divided by P0A will give you the mole fraction of solute. So that will be 0.8 minus 0.6 by 0.8, and that will be equal to the mole fraction of solute. So that is equal to 0.2 by 0.8, or 1 by 4, which is equal to 0.25. Okay, so the answer for this one is 0.25. So here we need to apply the equation relative lowering of vapor pressure. Then the value of Henry's constant Kh. So we should know the relation, like the Henry's law. We know that the Henry's law, P, according to Henry's law, P will be equal to Kh into psi n. So here psi, or the solubility, that is equal to P divided by Kh. So at a constant pressure, the solubility is inversely proportional to Kh. That means larger the Kh value, lesser will be the solubility. So the value of Henry's law constant Kh is greater for gases with higher solubility, greater for gases with lower solubility, constant for all gases, and not related to solubility. So that means different gases will be having different Kh value. And also this Kh value is temperature, it's a function of temperature. So definitely the same gas itself is having different values of Kh at different temperatures. So see, out of these two, greater, so the Kh is greater for gases with higher solubility, it's wrong, because Kh value, that means if a gas is having higher solubility, when a gas is having higher solubility, Kh value should be less. So gases for, greater for gases with lower solubility. So larger the value of Kh, lesser will be the solubility. The reason is that the solubility psi, that will be inversely proportional to Kh. And for this one related to that one, we have a question also, like the oxygen cylinders carried by scuba divers, it is diluted by helium instead of nitrogen. The reason is same, because nitrogen is having a Kh value around 76 and helium is having a Kh value around 144. So larger the Kh value, lesser will be the solubility of the gas. Okay. Then next one. How many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2 molar nitric acid? The concentrated nitric acid is 70% pure. So this is the second part of the question. That means the purity that we'll do at the end. So first let us calculate what is the weight of nitric acid solution required to prepare 2 molar nitric acid. So the relation equation is molarity will be equal to WB divided by MB into 1000 divided by V. So from this we need to calculate the volume of the solute, WB. So WB will be equal to M into MB into V divided by 1000. So that's equal to the molarity is given. Molarity is given as 2 molar, okay, into the solution that is about nitric acid, HNO3. And we know that the nitric acid, the molecular mass of nitric acid is 63. So 2 into 63 into volume is mentioned as 250 ml. So 250 divided by 1000. So 4, then 2, so 31.5 gram. 31.5 gram is the weight of nitric acid. That means if you have a nitric acid bottle, when you are having a nitric acid bottle, 31.5 gram of nitric acid must be taken. But the nitric acid bottle from which we are taking, it should be 100% pure. If the nitric acid is 100% pure, then if you take 31.5 gram from that nitric acid and dissolve in 250 ml water, we'll get like the required amount of molarity will be observed. But here it is mentioned it is only 70% pure. 70% pure means you have to take more amount, because if you say 70% pure means 100 gram nitric acid, 100 gram HNO3, it contains only 70 gram HNO3. That means if I am taking 100 gram from that bottle, if I am taking 100 gram of HNO3 from the bottle, like theoretically I am getting only 70 gram. The remaining 30 gram will be like water, because nitric acid will be like diluted in water. So in order to get the correct weight, okay, the required weight, that means the required weight will be the calculated value into 100 divided by purity. That will give you the answer. So the calculated value is 31.5. So the answer is 31.5 into 100 divided by purity is 70%. Okay, then it will be like 315 divided by 7. So the answer is 45. Means when you take 45, if you take 45 gram of nitric acid from this bottle, actually we are getting only 31.5 gram of nitric acid, because it is only 70% pure. So purity must be considered. So normally if this question is, if the concentration is not provided, means we are taking it as 100% pure. So if it is not 100% pure, means we have to take more amount. That depends upon the purity. So if X is the purity, then you have to multiply like 100 divided by X. The answer must be multiplied by 100 divided by the purity value. Okay. Then next one, the vapor pressure of two liquids P and Q are 80 and 60 torr respectively. The total vapor pressure of solution obtained by mixing 3 moles of P and 2 moles of Q will be. So vapor pressure of two liquids P and Q are 80 and 60, it is mentioned. So these are the vapor pressures of the pure liquids. Okay, so here P0A, so two liquids, so here vapor pressure of P. So we can write that is equal to 80, and vapor pressure of Q, that's equal to 60. Now the total vapor pressure of solution obtained by mixing 3 moles of P and 2 moles of Q. So we know that P total is equal to PA plus PB. Like P total is equal to PA plus PB. So the PA is equal to P0A into mole fraction of A plus P0B into mole fraction of B. So here the pure vapor pressures are given as 80 and 60. Okay, and now we need to calculate the mole fraction. So the mole fraction value, for example, the total vapor pressure obtained by mixing 3 moles of P and 2 moles of Q1. So 3 moles of P, so P will be 3 and Q will be given as 2 moles. So mole fraction of P, or number of moles of P, is 3 and the number of moles of Q is equal to 2. So mole fraction of P will be equal to number of moles of P divided by total number of moles, 3 by 5. And mole fraction of Q, that will be equal to 2 divided by 5. So the P total will be equal to, now the vapor pressure of P is 80. So 80 into 3 by 5 plus vapor pressure of Q will be 60 into 2 by 5. 80 into 3 by 5 plus 60. So 80 divided by 5 is 16. So 16 into 3, 48, and 60 divided by 5, that's 12. So 12 into 2, 24. So 48 plus 24, so the answer will be 72 torr. Okay. Then, which of the following binary liquid system shows positive deviation from Raoult's law? So when you consider the NCERT, in NCERT you are provided with the positive deviation, negative deviation, and the ideal solution. So the example for positive deviations are like ethanol and acetone. Ethanol plus acetone, then carbon disulfide and acetone. So these are the two examples which are given for a positive deviation, and so the answer will be option B. And in case of negative deviation, you have phenol and aniline. Phenol plus aniline is there. Then we have chloroform and acetone. Okay. And for ideal solution, like ideal solutions, example benzene and toluene, normal hexane and n-hexane and n-heptane, then so these are the examples. So anyhow, for this particular question, carbon disulfide and acetone, the mixture will be showing positive deviation from Raoult's law. Now, Pa and Pb are the vapor pressure of two pure liquids, A and B, to form a binary solution, and if Xa represents the mole fraction of A, the total vapor pressure of the solution will be. So we have the equation, see, P total. So normally P total is equal to P0A plus mole fraction of B into P0B minus P0A. This is the equation, or that can be P0B plus mole fraction of A into P0A minus P0B. Now here, instead of P0A and P0B, they have given it as PA and PB. So the answer will be like PB plus, or it will be P0B plus mole fraction of A into, so option D will be the answer, isn't it? P0B plus mole fraction of A into P0A minus P0B. Instead of P0A and P0B, they have given it as PA and PB. Anyhow, this will be the answer. So it's a direct equation, okay. Next one. KH values for argon, carbon dioxide, formaldehyde and methane are 40.39, 1.67, then 1.83 into 10 raised to minus 5 and 0.43 respectively. Arrange these gases in the increasing order of their solubility. Okay, now we have different gases are provided. So we'll see the KH value for each gas. For the question is not clear. Now please go through the question and we'll see the values. Okay. Now here for argon, the KH value is provided as 40.39. Then for carbon dioxide, the value is 1.67. Then for formaldehyde, HCHO is having the lowest value 1.83 into 10 raised to minus 5. And for methane, the value is given as 0.413. So I have already mentioned the solubility of a gas is inversely proportional. KH value is inversely proportional to, or solubility is inversely proportional to KH, or KH is inversely proportional to solubility. So here, now we need to take the gas which is least soluble. Okay, so argon, it is having the highest value. So argon will be the least soluble gas. So argon. Then the next higher value is carbon dioxide. Okay, so argon, carbon dioxide. Then you have the next value 0.413, methane, CH4, and the last value is HCHO. So here HCHO or formaldehyde is having the minimum value of KH. Since it is having the least value of KH, that will be highly soluble. So the answer will be argon less than carbon dioxide, less than CH4, and less than HCHO. So answer will be option C will be the answer, right? Okay. Then it's a match the following type question. So match the laws given in column 1 and expression given in column 2. So Raoult's law, then Henry's law, elevation in boiling point, depression in freezing point, and osmotic pressure. So in this one, Raoult's law is equal to, or we can say that P is equal to, or P total is equal to P0A into mole fraction of A plus P0B into mole fraction of B. That means A matches with R, isn't it? A matches with R. Then Henry's law will be P is equal to KH into psi. That means B matches with S. Then I think that sometimes it will be enough. Okay, AR and anyhow we'll complete it. Now elevation in boiling point C. Elevation in boiling point will be delta TB, that's equal to KB into M. 1 minute. I think I made a mistake. So here elevation in boiling point, isn't it? C matches with S. C matches with, that means elevation in boiling point, delta TB is equal to KB into M. Then depression in freezing point, D. D matches with P. Delta TF is equal to KF into M. And differential in freezing point is delta, so D matches with P. Then osmotic pressure pi, that will be equal to CRT. So E matches with Q. Then Raoult's law, A. Now Raoult's law is P is equal to P0A into psi A plus P0B into psi B. So A matches with R. Then Henry's law, B. Henry's law is T, that is equal to KH into psi. So AR, BT, CS, DP and EQ. Option A will be the answer. Okay, so just with all these are equations are directly given. Okay. Then now these are the questions from chemical kinetics. Now for the reaction 2A plus B giving 3C plus D, which of the following does not express the reaction rate? So it's a direct question. So we, according to this equation, the rate of the reaction will be minus 1 by 2 into dA by dt, that is equal to d minus dB divided by dt, and that will be equal to, now in terms of reactant will be multiplying by a minus sign, and then 1 by 3 dC by dt, 1 by 3 dC by dt, and is equal to dd divided by dt. So in case of that, only thing is that in case of reactant, you will be multiplying by a minus sign. The negative sign indicates that the concentration of reactant keeps on decreasing during the reaction, and the product, since it is increasing, you don't want to multiply by a negative sign. And here, so you have minus dB by dt is correct. So you need to identify which is not the correct expression. Okay. So see here, minus 1 by 3 dC by dt, because C is the product. And no need to mention negative sign along with the concentration of product. So option D is the wrong. That means in the rate equation, or in the writing the equation to express the rate, will not be using minus 1 by 3 dC by dt, but it will be plus 1 by 3 into dC by dt. Now this question, for the reaction A plus B giving C plus 2D, some of the experimental result in 3 trials are given. And now we need to calculate the rate law for the reaction. So rate law, as you know, like it is an experimental concept. So A plus B, now you are having A plus B giving C plus D, A plus B giving C plus 2D. So here the rate equation or the rate law will be rate is equal to K into concentration of A power X into B power Y. Concentration of A power X into B power Y. And now we should know what is the power of, that means what is the value of X and what is the value for Y. And now you can make, there are 2 attempts, like you can, either we can make the rate equation from the given data. And now listen here, or else we can directly, we can go from the data itself, the data itself will be enough. Okay. Now here, the values are provided. Now compare, now when you are having 2 similar values, okay, we'll take the values of B. So here the values of B in first and second trial, the molarity or the value of B is same, it is 0.2, 0.2. That means B will not affect, B is not affecting the rate of the reaction, because the concentration is same in both the trials. But here the concentration of A is doubled, isn't it? From 0.4 it is doubled to 0.8. When concentration of A is doubled, see, the rate of the reaction remains same, it is 5.5 into 10 to the power minus 4 and 5.5 into 10 to the power minus 4. Which means when concentration of A is increased, it is not influencing the rate of the reaction. And hence, the reaction rate is independent of concentration of A. So here it will be, now we can say that it will be A to the power 0, because A will not be involved in the rate equation. Because if A is involved, then that will influence the rate. Anyhow, the concentration of A is not influencing. Okay. Then, now we'll take 2 values where A is constant. Okay, we'll take 2 values where A is constant, because 0.4, 0.4. And now when concentration of B is doubled from 0.2 to 0.4, see, 5.5 into 10 to the power minus 4, it increased to 2.2 into 10 to the power minus. That means the increase is almost 4 times. Okay, the increase is almost 4 times. So here when it is increased by 2, when concentration of B is doubled, the rate of the reaction is increased by 4 times. So we have to see 2 power x. So what power of must be given for 2? So the answer is 4. That's enough. Okay. So here x should be equal to 2. So we can say that the power of A is 0 and the power of B should be 2. So the answer is rate is equal to k into A power 0 into B power 2 will be the answer. Now next question. Activation energy of a chemical reaction can be determined by. So actually activation energy EA, as you know, the rate equation K is equal to, so we have the equation K which is equal to A into e power minus EA by RT. And in order to evaluate the activation energy, we can compare the rate constant K at 2 different temperatures. Like we'll take the, because temperature K value will depend upon the temperature. And when temperature is increasing, there will be an increase in the K value also. So that activation energy will also be giving a constant value. And here the equation is log K2 by K1. Log K2 by K1 is equal to EA by 2.303 R into T2 minus T1 divided by T1 T2. Okay. So here the activation energy is evaluated by comparing the rate constants at 2 different temperatures. Okay. So here evaluating the rate constant at 2 different temperatures. Option C will be the answer for that particular question. And also remember, you just by heart the value of 2.303 R, because if the answers are given in Joule, then R will be 8.314 and that answer will be 19.15. Okay, so instead of multiplying 2.303 and 8.314, the answer is 19.15. So if you are getting any question based on that, that will be easy for you. Then the rate of a reaction is doubled for every 10 degree rise in temperature. Then the increase in reaction rate as a result of temperature rise from 10 degrees Celsius to 100 degrees Celsius. Listen, in this question, the temperature is raised from 10 degrees Celsius to 100 degrees Celsius. That means there is 90 degrees Celsius is the increase in temperature. That means 10 degree, that means we are having 9 times 10 degrees Celsius temperature is increased. And in the beginning it is mentioned for each, the rate of the reaction will be doubled for each 10 degree, for every 10 degree rise in temperature. So if you are having 9 times, if 10 degrees Celsius is increased, then it will be like 2 to the power xn. So where x indicates each 10 degree rise in temperature. But I am giving this 2 because the rate is doubled. Okay. If it is mentioned as tripled, then we have to give it as 3 power x. So the total increase in the rate of the reaction will be 2 power x, or that is equal to 2 power 9, and 512 will be the answer. That means when temperature is increased from 10 degrees Celsius to 100 degrees Celsius, the rate of the reaction will be increased by 512 times. Okay. Next one, the activation energy question related to forward and backward reaction. So if the activation energy in forward reaction direction is 150 kilojoule and reverse reaction is 260 kilojoule. So here the activation energy in forward direction is less than the activation energy in backward direction, and that indicates an exothermic reaction. Because in an exothermic reaction, the activation, so let us go for a graphical representation of energy and reaction coordinate. Now exothermically the graph will be like this. Okay, now reactant and product. And in this graph they have mentioned the activation energy in forward direction is 150. That means this value. This value is given as 150 and this is the activated complex. Okay. Now the energy for the activation energy for the reverse direction, that will be 260 kilojoule. That means from product to this is 260 kilojoule. And now you are asked to calculate the enthalpy of the reaction. The enthalpy of the reaction will be the delta H value. So this delta H is the enthalpy of reaction. And from the given graph, now it is clear that delta H will be like activation energy of backward direction minus activation energy in forward. So that's equal to 260 minus 150, isn't it? So 260 minus 150 will be around 110. Okay. But here the process is exothermic. Since the process is exothermic, you have to give the sign. Okay, so that will be minus 110. So it's because if it is just mentioned as 110, that means delta H is equal to 110. Magnitude is correct, but in order to indicate the direction, because heat is liberated, it is an exothermic process, so the answer should be minus 110 kilojoule per mole will be the answer, and not 110, okay, because the process is exothermic, right? Next one. The rate constant of a first order reaction is 6.9 into 10 to the power minus 3 second inverse. So rate constant K is given and it is mentioned it's a first order reaction. So 6.9 into 10 to the power minus 3 second inverse. Take care, the unit is given as second inverse and in the answer also it is in second. So no need of any conversion. How much time will it take to reduce the initial concentration to its 1/8th value? So the initial concentration must be reduced to 1/8th value means 1/8th value means 7/8 of the reaction must be completed. So we are calculating the time required to complete 7/8 part of the reaction because only 1/8 is left. Okay. So here we'll do like in case of if you know the value of T half, that can be calculated, but because K value is given, then T 3/4 will be equal to 2 into T half. Okay. So we have some shortcut formula. So T 3/4 is equal to 2 into T half. Then T 7/8 that will be equal to 3 into T half. Then T 15/16. So 16 means it is 2 raised to 4. So 4 into T half and so on. So here we will be applying the formula T 7/8 is equal to 3 into T half. Okay. So we need to calculate what is the T half value first. So our answer is T 7/8 is equal to 3 into T 1/2. Now T half is equal to 0.693 divided by K. So that's equal to 3 into, now T half 0.693 divided by, now listen, the answer is given as K is equal to 6.9 into 10 to the power minus 3. So on solving this one, so you'll be getting 3 into 693 divided by 6.93. So that will be like 100, isn't it? So 3 into 100. So the answer is 300 seconds will be the answer. So the question is they are asking to calculate 1/8 of the reaction is complete. That means the time required, how much time will it take to reduce the initial concentration to 1/8? That means 7/8 of the reaction is complete. So we are calculating the time required to complete 7/8. So that 1/8 will be remaining. Hope it is clear. Now the next one. A reaction proceeds by first order. 75% of the reaction was completed in 32 minutes. The time required to complete 50% of the reaction. See, either we can go by the direct method because we can use the equation like T is equal to 2.303 by K log R0 by R. And it is mentioned like the K value because time required to 50% completion means we need to calculate T half. That's equal to 0.693 divided by K. So from this equation first we have to calculate the K. But here it is not required because we have a relation T75% is equal to 2 into T50%. T75 is equal to twice the time required to complete 50%. So here T75 is given as 32 minutes. So 32 is equal to 2 into T50. So T50 will be equal to 16 minutes. Okay. So 16 minutes will be the answer. Then next one, half-life of a first order reaction is 4 seconds. Half-life of a first order reaction is given as 4 seconds. Then the initial concentration of the reactant is 0.12 molar. The concentration of reactant left after 16 seconds. Because we know that in a first order reaction, the half-life period is independent of the initial concentration. Whatever be the concentration of the reactant, the half-life remains the same. For example, if you have 100 gram of reactant and if it takes 1 minute to convert to 50 gram, then from 50 to 25 gram also it will be taking the same time. So here half-life is mentioned as 4 seconds. T half is given as 4 seconds And what is the amount of reactant left after 16 seconds? 16 seconds means it will be covering 4 T half, because it is 4 into 4, which is equal to 16. That means you need to calculate the concentration of the reactant after 4 half-lives. So the answer will be like, we can calculate directly. So 16. So 16 in the first half-life. In first half-life, that 16 will become, sorry, it's 0.12. 0.12 will become 0.06 in first half-life. Next half-life, it will become 0.03. Now 2 half-lives are completed. Next one, it will become 0.015, isn't it? And then it will become 0.0075. So 1, 2, 3 and 4 half-lives are completed. So after completing 4 half-life, the concentration will be 0.0075 molar. Or we can apply the direct method. The direct method means we will be calculating the concentration of a reactant using the first equation itself. K is equal to 2.303 by T log R0 by R. That also can be used because R0 value is given as 0.12. And you are asked to calculate the value of R. And in order to calculate the value of, isn't it, the K value, that also can be calculated because the half-life period is given as 4 seconds. So K is equal to, or T half is equal to 0.693 divided by Kn. So from that one you can evaluate the value of K and it can be substituted, but it will take a lot of time. So no need of such calculation because we know that this particular value will be after completing 4 half-lives. Okay. Then next one. This is also a question related to calculate the rate equation. Okay. For that one we have done a similar question in the previous case also. So here what we have to do is we'll be comparing the two concentrations which are having the same value. Now let me take the case of B. Okay, in case of B, now here 0.035 and 0.035, they are having the same value. Now here the concentration of A is doubled, isn't it? So we'll keep one of the reactant kept constant and another one the concentration will be increased. So the concentration of B when it is kept constant and the value of A is doubled. Now you compare the rate. The rate is same. That means rate is increased by 1 time. So here it will be 2 power. So that means we need to identify what power will be giving for 2. So the answer is 1. So the power of A should be 0. So the power of A will be 0. Now we'll compare the case of B. Now here A and A, in experiment number 1 and in experiment number 4, A is having the same value and the concentration of B is doubled. From 0.035 it is converted to 0.07. When it is doubled, the concentration is increased by 8 times. Like 0.1 will become 0.8. So 2 power what value will give you 8 means it will be 2 power 3. So the answer will be the power of A will be 0 and power of B will be 3. So the rate equation will be rate is equal to A power 0 is 1. So K into B power 3 will be the answer for that one. Okay. Now we'll move on to the last question. The rate equation for a reaction is given as N2O is equal to N2 plus R42 is the reaction and the rate equation is K into N2O raised to 0. So that raised to 0 indicates it's a 0 order reaction. It's a 0 order reaction. If the initial concentration of the reactant is A, initial concentration is given, that means R0 is given as A, then the half-life period of the reaction. We know that for a 0 order reaction, T half is equal to R0 divided by 2K. So that will be equal to, so R0 is given as A divided by 2K will be the answer. So the answer is T half is equal to A divided by 2K. So these are the questions that we have discussed from the 3 chapters. Hope it is clear for everyone. So thank you all. Bye.